This is a demonstration of building and running sample code, which adds a new symmetric encryption algorithm to Microsoft Windows Vista. This is accomplished via an application programming interface called CNG. CNG stands for Crypto API Next Generation. The main benefit of CNG versus the older version of Crypto API is that CNG makes it much easier to plug in a single symmetric algorithm. I'll be demonstrating the extensibility of CNG in the context of a public standard called CMS. CMS is the cryptographic message syntax and IETF standard. CMS is the cryptographic foundation of other security standards including SMIME, which is a standard for encrypting and digitally signing MIME-encapsulated email. In other words, if you want to encrypt your email with a custom algorithm, this sample shows you what you need to implement. The algorithm I'll be demonstrating as a plugin is called Twofish. Twofish is a symmetric key block cipher and one of 5 finalists for the advanced encryption standard. Although Twofish didn't win the AES competition, it is still considered to be quite secure. It is unpatented, and license-free source code is available for download. Let's get started. The sample code is available for download. I'll show the link at the end of this presentation. Once the code has been downloaded, the first step is to build it. Open a Visual Studio 2005 command window and change to the directory that holds the CNG sample solution file. I use msbuild.exe to build Win32 release type binaries from the command line. Now change to the release subdirectory where the built binaries are located. CNG configuration requires that all plugins be loaded from the System32 directory. Thus, the first step is to copy twofish.dll to System32. The next step is to register the plugin via regserver32.exe. To run the tftest.exe test program, first copy it to another directory. It simplifies debugging to ensure that there's not a copy of the twofish.dll plugin in the same directory as the test. Run tftest.exe from the command line and observe that it performs the following steps. First, create a temporary certificate for an imaginary message recipient. Next, use 256-bit Twofish to encrypt a test message to that recipient. Finally, pretend to be the recipient, decrypt the message, and compare it to the original. Since the decrypted message matches the original plaintext, I conclude that the Twofish plugin is working correctly. I'll highlight the most important features of the sample code for the Twofish plugin. The plugin implements 3 public interfaces. First, see g_tf cipher function table in the sample code file cng.cpp. The bcrypt cipher function table interface defines a symmetric algorithm plugin for CNG. You can see that the typical cipher operations are all represented here: generate key, encrypt, decrypt, etc. Second, see tfcng gen content encrypt key in capi2.cpp in the sample. It implements the cmessageoid cng gen content encrypt key func interface. which allows a new type of content encryption key to be created by CMS. Finally, see TFCNG import content encrypt key, also in capi2.cpp. It implements the cmessage-oid CNG import content encrypt key func interface, which allows a new type of content encryption key to be imported, typically after having been decrypted or unwrapped by a recipient. That concludes this demonstration of the Twofish plugin for CNG and CMS. In summary, I've shown how to build, register, and run the sample, and I've highlighted the most important portions of the implementation. For more information, or to download the sample code and accompanying article, please check out these links. Have fun!